Okay, so our next topic, which it would be nice for us to lab OSPF and NAT and go in that order as far as talking about theory and to labbing, but you know, I am very flexible in this, so we are going to do something a little different, and that is continue on with the topics and then come back doing the labbing once I figure out how I'm going to utilize my space. Okay, which I haven't figured out yet. So, and the space that I have now, having my main computer, my work computer, is the priority. Gotta work, okay? So, that is taking up all my desk space, and I haven't figured out how to uh, get to my computer, get to my equipment yet. And I'm not having it set on my desk anymore, which is what I was doing originally, because of the weight. So it is what it is. So now, our next topic. Okay. Okay, this is kind of weird because I don't know why we talk about circuit types here. I guess because frame relays in there, but this is actually mislabeled. But what we're going to talk about is tunnels. Okay. Now, tunnels are one of my favorite technology. Okay, and what we have to look at is what we're doing with a tunnel is we're creating from one router to another, okay, a virtual interface, okay, a logical interface. It's not real, but the router treats it as a real interface, okay. And what we are doing is we are digging a tunnel, okay, from one location to another, okay. Now, what does that really mean? Okay, so let's look at it this way. Couldn't remember the name of the program. Okay. All right, and I gotta fix that. All right, so now, let's. Oh, is it not gonna let me? Stop. Okay, I think we got a visual issue. So, let's go to our drawing program, and then just do it here. Okay. All right. So here is our Earth. Okay. And here's a house. All right. I'm doing this with a mouse, by the way. So, drawings are gonna be horrible. Okay. So this is our source, and this is our destination. Okay. Now, to get to this house, okay, we got so many avenues, okay, until we actually get to the road that gets us to the house. Okay? All right? And bam, we're there. Okay? Now, I don't know what this is, but nonetheless, okay, that means every one of these turns, okay, is a router making a different path or changing the path or the direction of the actual path. Now we gotta understand, okay? That is why we look at our routers in our same. Even though they're in our own domain, we look at them as separate entities because every router has to make a choice on where that traffic is going. Okay? And if it doesn't have a route for that destination, it gets dropped. I mean, there's no way for it to go. Okay? And the original router who sent it has no idea it got dropped. His job was done the moment he sent the packet out the interface was supposed to go to. Okay? Now, so we can look at this being router 1, okay? And this being router 2, all right? And so having our having our route coming from here over to here, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 routers down the road. Okay? And we also got to understand when we ping from this PC to this one, okay? All right? And let me rephrase that, okay? All right? It's not PC, it's router to router. Okay, what we're doing is a lot, wave, depending on the actual direction. Oh, I'm saying that wrong. I am depending on the routers downstream that I know nothing about. Okay, because this connection is to the internet. Okay, so all this is happening without my ability to know, my ability to understand, my capability of doing any type of knowledge on this internal internet cloud. Okay, so all I know is the IP address of here. All right, and the IP address of here. Okay, now that's good, but every time I have to know that this interface is valid, and I'm talking about this one right here, okay, is valid, is I have to physically go on this router and ping it, okay, and say, all right, I'm getting replies back, and that interface is valid, okay? That path to that destination and back to me, from that destination to me, okay, is now valid, okay? And that's what our pings are going to test, all right? But on router 1 and router 2, I'm going to create these logical interfaces, okay? All right? And because each router is its separate entity, I'm going to give them the name Tunnel 1. Tunnel 1. Okay? Sorry, that's the best I can do with a mouse. Okay, so now, here's the thing. Under the tunnel interface, I'm going to give it an IP address. Okay? I'm going to also use the command of tunnel source and tunnel destination. So here's my tunnel source and my tunnel destination. Okay? The tunnel source is obviously going to be the IP address of this interface, and the destination is going to be the IP address of this interface. Okay? Both routers are going to have the same configuration, except its tunnel source and destination are going to be the opposite. Okay? So, on router 2, my tunnel source is going to be this interface. My tunnel destination is going to be this interface. Now, here's the thing. Okay? 10 hops down the road, once I configure this tunnel interface, it goes out and it has to find out if that destination is valid. And it does. Now this router has to make sure its destination IP address is valid. And it is. And because of that, this tunnel is now going to come up in a up status. And at that point, I will be able to ping the IP address of router 2's tunnel, okay, as if that tunnel interface is directly connected to this tunnel interface. Okay? Now, if you look at it from a ground perspective, like my house is sitting on the ground, okay, look how I drew the interfaces. It's literally a tunnel. I dug a tunnel from the route from house 1 or router 1 to router 2, Okay, giving me a direct, logically, a direct point-to-point connection. Okay? Tell me that's not fascinating. Okay? Now, keep in mind, logically, now physically, if this was physically underground, we could physically go underneath the tunnel to get to this, okay? And avoid all these turns and streets to get to the house. Okay? A lot easier. Alright? And you also gotta understand, okay, if I was trying to get to router 2, from router 1's perspective, okay, it's 10 hops away. But once I create the logical tunnel, it's only 1 hop away. Now tell me, that ain't some cool ass shit. Okay? Alright? So, these two routers are working together to create this logical interface and give the illusion that they're directly connected. Meaning that if I'm learning routes from router 1 that are EIGRP routes, okay, it's going to send the traffic this way until it's learned from the tunnel. Now the tunnel has a much lower metric, so we're going to take the path of the tunnel. Now, have no illusions. There is no logical without the physical. Okay? So, I might be sending it out the tunnel, but what I'm really doing in reality, okay, is still going the physical path of that packet 10 hops down. So router 1 and router 2 has created this logical interface, but there is no physical tunnel there. It's logical. And the physical path must be the 10 hops it takes to get to the destination. So any router down this path that dies and can no longer forward that packet to router 2, the tunnel dies. It collapses. Okay, which will make sense because if the ground becomes unstable from any point from here to here, okay, the ground, okay, will cave in on the tunnel and kill the tunnel. Okay, you can't go any farther. Same concept. Okay, now let me see if I can explain this correctly. The tunnels are built on a foundation, and that foundation is going to be the path, the physical path from your source and destination IP addresses from router 1 to router 2 and from router 2 to router 1. Okay? Any disruption of that path going from router 1 to router 2 back to router 2 to router 1, the tunnel caves in. It dies. So, if we are building tunnels on routes that are learned through a certain method and the tunnel is built, however, what you have done is you allowed that tunnel destination, destination route on from router 2's in router 1's routing table to be learned through the tunnel. So now the tunnel becomes a better path for router 2 interface that is facing the internet. Not a good idea, because what's going to happen is now router 1 wants to take the tunnel to get to that destination, and how can it use the tunnel? If the tunnel is in there, that means if it's learning the tunnel is a better route, then the original route gets removed from the routing table. And then all of a sudden, something's going to really happen. Your tunnel drops. Because you can't learn it from the tunnel and expect the tunnel to be built on the destination of the tunnel when the tunnel was already formed and is only stable because of the original path to router 2, which is not through the tunnel. That's why I built this ground here. Okay, so your source and destination IP addresses, okay, must be set in a way where they're not being learned from the tunnel in order for the tunnel to be stable. Now, this is one of those things where it is best to lab it. Okay, because what's going to happen is the source and destination, or whatever, the destination is learned from the tunnel. Okay, now the original route that it took to build the tunnel has died. It's no longer in the routing table, and now the tunnel drops because it has no foundation anymore. Okay, now that tunnel interface learned route gets removed from the routing table, and the original route goes back into the routing table. Okay, building the tunnel and having the tunnel come back up because now the actual foundation is solid. And now you have this tunnel going up and down, up and down, up and down. And it will not stop because this behavior will keep going back and forth, back and forth. So, if I am learning routes through a routing protocol of the tunnel, the only way to stop this is to make sure that the routes of the interface that you are building the tunnels on is not advertised in the tunnel through the routing protocol. Once you do that, okay, and eliminate that route from being learned on either side, router 1 or 2, the other router's internet-facing IP address, stop that from being advertised through the tunnel, and your tunnel will remain stable. Okay? So remember, why build tunnels anyway? Well, there's nothing better than having all these routes to go through. Okay? Your tunnel is a logical connection from one router to another. Okay? Meaning that as long as you see that tunnel in up status and it's able to ping from tunnel 1 to tunnel 2, from tunnel 1 router 1 to tunnel 1 router 2, your route throughout the internet, whether it's 50 hops down the way, is solid. And then also, now from that perspective, you're not caring about that, but what you are caring is that your branch office is able to communicate with your headquarters, because when you log into the headquarters router, okay, because all your branches are connected to the headquarters, all right, and you have tunnel interfaces that you've built from the headquarters to every branch. Okay, so when the branch loses connectivity, okay, the first thing you will see is log into the headquarters router and see that tunnel's down. Okay, the tunnel's down. That's why they can't get to the resources. Okay, all right. A lot of times the branch will have to go through the headquarters in order to get to an internet connection. Okay, because we're going to give them internet. Okay, but these are branch employees, and we want to monitor all their traffic. Okay, so we're going to say, look, if you want to go to the internet, that's fine, but your traffic needs to come up to headquarters, okay, first, and through our firewalls, and be allowed. Okay, period. Okay, so that means once they lose the tunnel interface connecting to the headquarters, okay, they lose internet connectivity, but that's not why they're going to call the NOC. They're going to call the NOC and say, we can't get to the internet. All right, so you, the network engineer, logs into the headquarters and be like, oh, well, shit, the tunnel's down. Okay, So let's go find out what's going on. Okay, it could be as simple as a change was made the other day, and someone made the change on the wrong interface, killing the tunnel. Okay, all right. So that is one thing. Another cool thing is, okay, and I have demonstrated this in a class once. Okay, and let me see if I can draw this out. So, um, here I am, Kyle. Okay, all right, and here's George. Okay, and here is Robert. Now, here's the thing. These routers are sitting inside a PC in GNS3. Okay? That router in GNS3, we can actually make a cloud interface, which the cloud interface is cool because what you do is you bridge the physical interface of your computer to the cloud, okay, and then the interface of the router goes to the cloud. Okay, now that bridge of your network interface plugs into your switch, okay, and then goes to your router, okay, all right, where it actually connects to the internet. All right, and everybody is doing this. All three people, okay. This is an emulator on your computer. All right, it's an emulator router. It's in GNS3, okay, and you're capable of doing this. And now, okay, they're all gonna do this, okay, through GNS3, okay, and then we are going to create tunnels, okay. And the reason why we're going to create tunnels is because once that tunnel is created, okay, once those tunnels are created, I don't have to worry about how the router, like my Verizon router or Comcast router, is going to handle the traffic because I was able to build these logical tunnels through GNS3 to GNS3, okay, by doing that. All right. Once I do that, I can create EIGRP relationships to the tunnel. Okay. And here's the best thing. Not only am I using the internet to create my own logical connections, okay, all right, I can encrypt that traffic. Oh my God. So now I am building my own infrastructure across the internet that nobody can read because the traffic is encrypted. I have now built my own internet on top of the internet. Okay, if you want to look at it from that perspective, or my own network over the internet. Tunnels are powerful tools, and no way, shape, and form. Okay, besides DMVPN, because it's the same concept, is there going to be a topic that I enjoy talking about more than tunnels. And to do this from GNS3 to GNS3, okay, all right, and create this storyline and show others how to build your own network, okay, privately across the internet, just using GNS3 routers, okay, was phenomenal. All right, now, never would I have ever thought something like this would be possible, okay, until I learned tunnels. And I'm like, tunneling is just awesome, guys, okay. Now, there's a layer 2 method of tunneling as well. It's called Q&Q, okay. And now, let's take a look at this. Actually, I'm going to use these shapes here. Let's do this. Boom. Haha. Actually, you know what? I want to do squares. Okay. So, here we go. Alright, so now. Can I do text? I need to figure that out. I don't think so. What is that? Oh, board. What is this? ABC. Text. Okay. All right. So now, I'm gonna type in. Okay, that is very small. So let's screw that. Um, what is this? Settings. Pencil. I don't see text. General. Okay. All right. Well, those are all the settings. So, oh well. All right. So, nonetheless, okay. Here's the thing. These devices are connected like so, and I can literally set up tunneling here. Oops. Let's go back. All right, and let's take the circle here. So I can actually, and not there, sorry. I can do my tunneling on this interface and on this interface. And now that tunneling makes the connection of this switch here, okay, and this switch here transparent of the other switches from point to point, meaning that the tunneling starts here, okay, and let's do it this way, where I have this tunnel, okay, and we're drawing this like a wormhole, right? Oops. Let's go back. Let's try this again. Okay, so there's our wormhole. And now switch 1, which is here, okay, and switch 2 are going through the tunnel as in they see traffic as if they are connected point to point. And in reality, they got to transit 3 switches. But they don't know that. Even the CDP neighbors are going to show them directly connected. What did I tell you about this beautiful technology of networking? Every rule can be broken. Okay? Tunneling is phenomenal. It will always be my favorite topic to talk about and discuss and educate on. Okay? So, let's talk about our generic routed encapsulation, which is called GRE. And why do we call it that? So, here's the reality. How am I going to do this? You know what? I think I'm going to do this with OneNote. So let's go ahead and clear this off. Okay. All right. Close this. All right. Okay. So here we go. The original packet is going to be source IP of, and let's zoom this in here. Where'd it go? Okay. 65.1.1.1 destination IP is going to be 45.1.1.1. Okay, and these routers, okay, are set up in different states, okay? All right, so now let's say 65 is in Maryland and 45 is in New York. Okay, so now here's the thing. What this packet does, okay, is it is going to encapsulate the actual IP packet with the GRE packet. And that GRE is going to say, let's say, IP address 192.168.1.1. Okay, all right, and it's going to be encapsulated again. Okay, which I can't do another one. Okay, so let's actually take this copy. Okay, and put it over here. Okay, because what's going to happen? Really, I can't move that up there. Thank you. Okay, so what's going to happen is, because I'm telling you it's a logical interface, and it is, but it's how the router does it. All right, so the original IP packet is going to be encapsulated with a GRE packet, and then we're going to put the original IP packet back in front to encapsulate it again. So now we got a GRE encapsulation and an IP packet encapsulation. Okay, so when it gets to the 45 address, it's going to say, well, that's from my IP address, and it's going to strip, okay, that information off. Okay, all right, and then it's going to look at the GRE packet and says, oh, this is coming from the other side of my tunnel with the IP address of 192.168.1. whatever, because obviously it has to be on the same subnet in order for it to be what? Pingable and reachable and communication, right? Okay, and then it's going to strip this off, okay, and it's done, okay, and that's how things come into the tunnel, okay, but we got to put the original IP on there to re-encapsulate it, because how are we ever going to get to the destination? The tunnel's only built by traveling the physical path that the packet must travel. So you might be one hop away, but that packet is going to take 10 hops down the road. Okay? All right? And that's how it's built. Now, this is not 100% detailed. Okay? All right? Remember, we're not doing that stuff just yet, going that deep. So, if you want to know more about that, do your own research. Okay? Now, that's why we call it general router encapsulation, because we're creating these GRE now, because the other side of the router has a tunnel interface enabled. It's listening for GRE packets, and it's going to know what that packet's for, and it's going to know, okay, which tunnel interface it needs to be assigned to. So if you actually looked at the behind the scenes, okay, when a packet comes in with that information in that encapsulation, it's literally going to say, okay, packet is coming in on the tunnel 1 interface, okay, which really isn't the truth. It came in on the FA interface. However, because of that GRE encapsulation, the router is going to make you believe it came in on a tunnel interface. This is important to understand, because people do get kind of confused when they're like, when it came on a tunnel interface. Okay, it might have came in on a tunnel interface, but what is that tunnel interface tied to? How is that tunnel interface possible? It's only possible because of the incoming traffic of your source IP address of the tunnel, which is Fast Ethernet 00. Okay? You can't have logical without the physical. Don't ever forget that. Okay? So, this is based on how we drew that diagram. This is a point-to-point solution. Well, this is great, because my routing protocols require point-to-point to have neighbor relationships. Okay? Alright? So, logically, from the router's perspective, okay, it came in on a tunnel. Alright? And it's going to tell you it came in on a tunnel. But coming in on a tunnel is coming in on the source address of the tunnel. That's why we have to define the source and destination address of the tunnel. And remember, your other router that's building a tunnel with you must have the source and destination switched. Okay, that's the only way it's going to work. All right? Okay, you have keep alives. Keep alives are a way of keeping an interface up, and if you miss so many keep alives, it'll bring it down. But trust me, when your tunnel loses its foundation and collapses, I mean, the protocol of that tunnel interface is going to go down. Okay? And if you can't ping the other side of the tunnel, guess what? Your tunnel is not working. It's down. Okay? I don't care if it's a VPN tunnel as well. Okay? All right? So, I mean, because that's really what VPN is. It's tunneling. That's what, I mean, VPNs are the coolest thing ever. Okay? All right? So, it says there's no security, but that's not true. That's not true, but generic routing encapsulation, yes, it can be hacked. Yes, it can be, it can see the traffic if someone captures it. But that's why we use a crypto, okay, and create our tunnel protection. And our tunnel protection, okay, will actually call for a crypto configuration that you configure, and that is what will be used to. Now you got to do it on both sides, by the way. Okay, all right. You can't encrypt traffic and expect another router that's not configured for encryption to decrypt it. It's not going to work. Okay, so both sides of your tunnels need to be set up for encryption. Okay, and that is your security right there. All right, so generic routing encapsulation or GRE, yeah, by default there's no security, but you can add it to it. So I don't like that statement, but I put it there, so we had to address it. So now we can run GRE within IPsec. IPsec cannot run multicast and broadcast. We're going to skip that because here's the thing. Okay, what I just told you about the encryption is us running IPsec over GRE. Okay, and when I say over, because this gets confusing a lot of times with people, even in documentation. When I say over, that means the underlining aspect is the GRE tunnel that must be built, and we are going to run IPsec over top of it. Okay, all right. So that IPsec over GRE, that's what that means. Okay, the multicast and broadcast, we'll deal with that later, and that's not really something that's up for discussion. And of course, GRE is IP protocol 47, which you will see in packet captures. Be strong, be determined, be Cisco.